Hello, we're back for another look at the Samantha fixture, but in this sense we're looking at the fork fixturing that is part of the system. I had thought I might have been able to put this off for a while, but I decided to go for it, and it was wise to. I caught a lot of things and improved a lot of things within the regular fixture. Just before we go into details here, if you notice, the tower caps have these holes here are on the 80-20 pattern of 1.5 inch spacing, and these are on a 2-inch spacing for Build Pro. They have their counter bores, and then we have an optical breadboard spacing here for Imperial Optical. I tried to populate most of the parts with provisions for anything that might come up in the future. And you can see down here at the base of the tower, were you to, let's open up the parts separately, were you to take it off, you'd have a number of useful setups. Maybe I should add a couple more counter bores to that, I don't know. But it's fairly useful. Oh, that thread needs to change. Yeah, that needs to go down because we shrunk that. I'll remember that later. And then we did the same over here. If you look at the axle holder, we added some more counter bores and some more threaded bosses. So that's pretty cool. We adjusted this clamp so it slides really nice and has just the right amount of room. Because I did the fork fixture, I had to shrink down to, I think it's 1 3/8 is the anvil specification for the width on this 1/2 inch section. Thus, there are 2 plates here that will hold axles, one for front and one for rear. And it's hard to get around that without doing some goofy stuff, and I'd like it to just be very macro. Anyway, that's fairly easy, but if you think about it, this plate and this plate had to be made for the initial fixture. We're just having a second one so we can have a second tower, and that's nice because our parts will get cheaper as we add more to the order, right? So we just doubled the quantity, and we have 2 towers now. Excuse me, I've had a wicked cold. So this clamp fixturing is really nice. I did a kind of a cool thing on it. Let's open up this part. I know I say that about everything. It's cool, it's cool, it's cool, but this kinematic constraint here, if we look, where's the center of the axle is right there. But notice I'm not building the material all the way up to the center. I've actually defined in my equation a kinematic contact face, and that's 6 millimeters. It's just showing in inches because we're in an inch document. But I've made the face there, the length of this, to be 6 inches. That means 6 millimeters, so it's 3 millimeters on either side of the contact. And because of that, if you notice, I can calculate, I don't have a keyboard in front of me, so it's going to be tougher, the top and the bottom of that slot. And because I know the top of it, I don't really need to build up any more than that. And I can conserve some material and use it in other productive ways. So that was kind of a cool kind of development there of improving these. And of course, this slot here that is generally just added for machining. All of this is to make machining easier, because a chamfer mill or something like that with a 6 millimeter face here is going to be a lot easier to find than something with like a 5/8 face. Now they're out there, but of course they're going to extend down into the bottom and everything like that. So this way I'm actually making it easier from a tool perspective, that the chances of someone having a great tool for the job are there. We have our slot here. This is an alignment pin to keep the the lug from twisting, and we go up. We can see the change when I go to the rear configuration, and simply the area widens. Nice, huh? Okay, and on this side, I actually was trying to build in a way, redundancy in terms of holding and adding a slot over this other side. Maybe I should do that and just have these be a partial thread through, because otherwise the thread interrupts there. But maybe I'll do a partial on those ones. But you can see that I can clamp down to a table using these four again. I narrowed this up. I found that was a little excessive the way I had it before. It's always nice to systematize as much as you can at the outset. You'll find later it's like, damn it, I wish I had done this. It's like, well, you can do that cheaply on the front side. Okay, so again, over here, if we look at there, these are the set screw holes for calibrating this tower, and this is a tension rod holding everything together. Anything else can be built on or is available if you should want to have some sort of construction, or simply add a lamp. You know, stuff as simple as adding a lamp is really cool, and having a place to mount that easily there is cool. One of the things about the way I did this, there's different ways to lay this out, especially if you have a table. I could have done it more flat, 90 degrees from what it is on the table. And that's probably perfectly valid. There are arguments for and against that. I kept it this way for now because by doing so, I get to leverage all of this system here. If you notice, my fork length is 420 and it's reading off of the frame fixture setting. My setting over here, if you were to read it, is correctly, it's 40 millimeters. There's an offset adjustment you have to make when you're reading there to correct for that. But it's 40 millimeters up because it has a 40 millimeter rake. So our X and Y on the axle setup is consistent for the fork and the frame. And this is the 0, this little pointer, and that simply points to the crown. And you notice that comes right to the center line there, because we're leveraging everything we've done already. We're trying to always when we make a tool, we want to have it do as many things as we possibly can. We want to have redundant features. We want to have different setups. And right here, it's like, boom, we're using parts we already machined for the frame to make a fork. Isn't that nice? The second tower. Now let's get into the steerer holder, because that was a little more challenging. So I discuss in the blog post about how I don't like the anvil fork fixture that I have. It's got this giant C-clamp and it's huge and it sticks out like that far off the fixture, and it clamps down an amazing amount, like enough to damage a steerer probably if you wanted to. And it's hard to move around, it's hard to store, it's just a pain in the butt. So I wanted something elegant, and I put a lot of time into this. I'm going to open that up as a separate file. So simple enough, we have our slot just like the rear, but we had to change the orientation a bit. Let's change the transparency there. So you'll notice to make the fixture work with the registrations of the frame, I had to bring this out to match 0. And I'm taking advantage of all that extra space for a slide nut on the back side. And I'm widening this hole out to make it easier to machine. I don't want it so small it's a pain in the butt. And our mounting bolts actually get countersunk to the face of that slot, and they go in there, and you can see the slot goes like that. This wasn't an obvious thing, but it looks like it works. I've changed some scales of things, and it clamps just enough, slides out of the way, doesn't fall off. I haven't yet included a spring, because a mechanism like this is actually very nice to have a spring pushing it away while it's untensioned against the part. I haven't done that yet. It eats up a little bit of space in a way that I don't want it to. If you notice when I'm here, let me go to the edge of, boom, there we go. So that's going to be the outside diameter edge of the steerer right there. I'm giving myself just a little bit of room in its native position where this chamfer crashes, and a little over travel in case of whatever, while it's loose or whatever. But I want that bolt as close as I possibly can, or at the very least as far away from the little block that sits on the surface. So we do have space constraints in there, which are pesky. Anyway, but we have a nice small 90-degree turn. I went with 5/16 screw threads for both the steerer and the axles. Just something to make them a little more durable because they're opening and closing a lot. Maybe one day they'll get helicoiled if the bare aluminum is too much. But again, we've got our counter bores. Oh, on this part, let's open it up. So on this one, I was able to do the double rail. These threads don't go in all the way, or they just project into there, but that's no issue. Yeah, and again, I lowered my face because we don't need, because of the kinematics, we only need a center line essentially right along there. So we can be a little bit more efficient and leave some more material for other things, or at least just making the tool hardier. I wanted to chamfer this end, but because of it going around these corners, it's a pesky one. I guess I could do the complex way of doing it. Just adding chamfer creates something that they'd need to do with a ball end, and we don't want to add that kind of cost. I'm trying to keep there's no need to do any ball end milling on these parts, because the minute you add that, it's crazy. All these chamfers can be done with chamfer mills or chamfering tools. Excuse me again. Yeah, so it's kind of cool. Cool. Let's save all, whatever. But I'll have these parts machined when I do the other parts as well. And that way it's all been thought through. I'm going to think about it for a few more days. Not much else changes down here. Just because I'm using these magnetic thread bosses like before. If you look here, I just make a little cylinder. It's kind of like a cylinder head alignment pin where the bolt passes through the pin that locates. And these are easy enough to machine. And then you can use these quickie mag threads. There's probably other ways of doing that. That's not a mission critical thing. It's just what I was thinking right now. I have nuts that I can thread into that I previously made for the Cyberdyne fixture that I can just do at the bottom without having to do this. So, but we're aligning on the table again. You know, this is that whole thing of like, we want to think of more ways to align it so that here the axle tower base is connecting to 8020. Here it's connecting to a Build Pro Siegmund type of raster. And that's what I'm looking for. I want to have any part that in my system just become usable somewhere else. Let's open up the fixture with the Millennium Falcon on it. We can look at some of the smaller updates that are there. Oh, what's cool about another cool thing about the fork fixture, you can make a fork as long as the table. You could make a fork with a 3-foot offset. You know, again, you're leveraging the table. So if you have a table or a gang of tables, that's how big your fork can be. Just like with a frame. That's how big your frame can be by using the whole table. And that extendability is really good. We're always looking for a way to do that. This is slow to update. Oh, I ghosted out the breadboard on these images just to speed up my computer. You can see that it's really chugging with the size of these files, especially when I'm switching entire configurations. It is actually doing something here, I believe. Yeah, we're waiting. See the pinwheel? We love the pinwheel. That means we haven't crashed yet. Huh. Come on. It was working faster earlier. Okay, there we go. So, Millennium Falcon, that was a 160 travel hardtail. So you can see that we have plenty of room here to add, you know, in the native configuration, we can go up to 200 or more if you want to extend this or get tricky with your table setup. But let's go to these sliders. Oh, come on. Sorry, life is great when you're dealing with large assemblies. Okay, let's open that up. Nothing's really changed on the cone front. Nothing's really changed on the clamping and everything like that. But I did ensure, we'll open up that part, that we have some rasters here, even though that's a 3-inch spacing. But then I added these 6/4 20 holes just to give us some options, and those go right through. And there's another pin out on this other side. So, oh yeah, that's right. That's for connecting the bolt through door. But here's the thing. I made those 5/8 of an inch counterbore, even though that's much bigger than is needed for that fastener. Why do we do 5/8? Because it works everywhere else. So if we're doing counterbores anywhere, we're trying to target 5/8. So a 1/4 inch fastener or a 5/16 fastener or anything metric in that range, let's just target 16 millimeter 5/8 for any counterbore. And then we have a dual use situation. Makes a lot of sense. And we have that at the top as well, just in case. Unforeseen stuff, you never know. All it has to do is save you once and you really paid for it. There we go. These are the tick marks for the head tube. Okay, so we added some more to those guys. Boom, boom, boom. And we made more clearance here so that that's accessible on the top. I always try to design as much as I can until basically I hit print. Hitting print meaning sending the files for the quote. I think that's it. So yeah, so the frame fixture saw some just detailing, but we got that fork fixture now, and we got more considerations here for our fancy CNC parts. We're going to do all that at once. Okay, so I hope this helps a little more. Continuous improvement here. Maybe another week or so of fiddling with this and ensuring that it will really do what I want it to do. We live in a virtual world until it's real, but real is so expensive that any little time, especially because it's hobby stuff, we don't want to waste any money, but we want to get the maximum we can for our money. Okay, well, thank you very much, and hope these videos are helping.